All right, this is a correction to 5.5 at the end. We're going to look at example number 4 here, monitoring progress. I figured out why the book says what it says here, because it says in example 5. So if we look at number 4, we have to go back to example 5 where we had f of x is the square root of x. F of x equals the square root of x. And g of x is the square root of 9 minus x squared. And g of x is the square root of 9 minus x squared. And they ask us, explain why you can evaluate f plus g of 3, f minus g of 3, f g of 3, but not f divided by g of 3. Well, here's what happens. If we take f and we put it on top, and we take g and we put it on bottom, we have to worry about a domain issue. You can't have 0 in the denominator. And so if we say the square root of 9 minus x squared equals 0, and then we square both sides, and we get 9 minus x squared equals 0, we add x squared, we say 9 equals x squared, and we square root. X is either 3 or negative 3. Well, so if you plugged in 3, you'd get a 0 on the bottom, which is an undefined situation. So that is a domain limit. You can't do x is 3 because the denominator would be 0. It's a domain limit. That's why. I was trying to do it for number 3's problems, but it was supposed to use example 5's problems, and that makes way more sense. You can't use a 3 whenever you have the square root of 9 minus x squared in the denominator. Doesn't matter if they're side by side, if they're subtracting, adding, or multiplying. You can always multiply by 0 or subtract 0 or add 0, but you can't divide by 0.